Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2023 paper 1. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Total time for this exam is 1 hour and 30 minutes. You need to answer all questions on this paper and total mark for this paper is 80. On the last page of exam, you can also find some important data and also some important formulae. In the exam, if you need any formulae or if you have forgotten any formulae, you can go to the last page of exam paper and you can double check. Some important formulae are given to you. And also in the exam you have to use value of g equal to 9.81 meters per second. You cannot use 10 meters per second. So these things are important. You need to understand some important formulae are given to you and some important data is also given to you. Question 1 says a quantity is either a scalar or a vector. Which row of the table is correct? In scalar column, if you look at this one, energy is a scalar, so this is a scalar. Momentum is a vector, so this is also true. This is vector, so it means this is correct, this is correct. So the answer for this question has to be A. If you look at next one, this is vector. This is in the wrong column. Acceleration is a vector. Time is scalar. Mass is scalar. Velocity is vector. Force is also vector. So the answer for this question is A. Second question says which of the following is an SI unit for momentum? So momentum, simply we need to understand momentum P is equal to mv. SI unit of mass is kg and SI unit of velocity is meter per second. So the answer for this question is A. And momentum is a vector quantity. You also need to understand momentum is a vector quantity. Question 3 says which of the following could be used to describe the elastic limit of a material? So first of all, let's try to understand what is meant by elastic limit. Elastic limit means this is the end of elastic deformation. So this is the limit. So simply we can say elastic limit simply tells us elastic deformation and plastic deformation. It simply tells us the value of the stress until that material behave elastically and after that material start behaving plastically. So this is the limit of elastic deformation. And at elastic limit, if we remove the stress, material will come back to original shape and size. So that limit we call is elastic limit. Now if you look at the given options, it is given to us the stress above which the material will not obey Hooke's law. This is not right actually. This is limit of proportionality. So this point is limit of proportionality. So this is limit of proportionality. So this is not possible answer. The stress above which the material will be deformed plastically when the stress is removed. Yes, because this is the elastic limit, end of elastic deformation. So this is our correct answer. And the stress at which the material undergoes a sudden increase in extension, that point is actually yield point. So we can say this is yield point. The stress at which the material breaks, that is the breaking stress. So we can say that is breaking or fracture stress. So these are the points you need to understand. Elastic deformation means that if you take your finger and you place on your cheeks, you see it deform. And then if you remove your finger, it come back. So this is elastic deformation. Question 4 says a ball falls through air from rest. Which of the following shows the graph of displacement against time for the ball? So for the ball we need to understand it started from rest. So the ball started from rest. So the initial velocity of the ball is equal to 0. When we drop the ball, this ball will accelerate. So we can simply say ball will accelerate. As ball will accelerate, it simply means that the speed of the ball, speed increases. Speed increases. Now if you look at the given options, we have displacement against time graph. So the gradient of displacement time graph, so we can say gradient of dt graph is representing velocity, or simply we can say is representing speed, or we can say is representing velocity. So it's better to say is representing velocity, because direction is also important. By convention, we take up is positive. So by convention, we take up is positive. As this ball is falling down, so it means that its velocity is negative. So the gradient has to be negative. And as the speed is increasing, so the gradient has to get steeper and steeper. So gradient has to be negative and gradient has to be increasing. Gradient has to be increasing. Now if you look at given options, option 1, option A, this is telling us displacement remains constant. So it simply means that v is equal to 0. The gradient of this one is 0, so v is equal to 0. And gradient of this one is constant. So this is telling us v is constant. But in this case, velocity of the ball is increasing. So this is not possible answer. This is also not possible answer. Now if you look at option D, the gradient of this one is decreasing. So this is telling us speed is decreasing. Even if we consider effect of air, speed is increasing. Speed will reach a terminal velocity, but speed is not decreasing. Acceleration is decreasing, but the speed is not decreasing. So when this ball will reach terminal velocity, its acceleration will be equal to 0, but it will have certain maximum terminal velocity. So when the ball will drop, its speed will go on increasing, but its acceleration will go on decreasing. Very important. So you need to understand speed of the ball will go on increasing and acceleration of the ball will keep on decreasing if we consider the effect of air as well. And so if you look at this one, this is telling us speed is decreasing. So because the gradient is decreasing, so speed is decreasing. So this is not possible answer. Now if you look at this one, this is telling us gradient is increasing. So it means speed is increasing. Gradient is negative. So it means velocity is negative, because down is taken as negative. By convention, we take up is positive. So this is the best answer. So the answer for this question is C. So this is how you need to understand. At this level, simply you need to understand what gradient of the graph is telling you and what is the area under the graph is representing. So these 2 points you need to understand. If you can figure out these two, questions about graph are very easy. Let me explain you a little bit more about option D, because some of you still will not be clear about option D. Why option D is not possible answer. So the best way to look at option D is, if you look at the question, it is given to you ball started from rest. And the gradient of dt graph is equal to velocity. So it simply means that the initial gradient has to be equal to 0. But if you look at the gradient of this, at this point, this gradient is not equal to 0. So this is telling us it has certain velocity. And at the end, if you look at the gradient here, this gradient is equal to 0. This is telling you the final velocity is equal to 0. So this is like if you throw the ball from the ground, the ball go up, then ball finally reaches the highest point. So here speed of the ball will be equal to 0, and here it has certain velocity v. So the motion is like this. So that's the reason D is not answer. So the best way is look at the gradient. Gradient at time t is equal to 0 has to be equal to 0 because it started from rest, and the final velocity should have some value, because in the air it will reach terminal velocity, and terminal velocity will not be zero. So the answer for this question is C. I hope it is very clear now. Question 5 says a helicopter moves vertically upwards with an increasing speed. Which of the following describes the increase in gravitational potential energy of the helicopter? So first of all, imagine that helicopter is moving upwards with constant speed. So we can simply imagine this is the helicopter. Let's say this is moving vertically upwards with constant speed. So we can say speed is constant. So it means that in this case, helicopter is not gaining kinetic energy. So we can simply say in this case work done is equal to work done by helicopter. This work done will be equal to change in gravitational potential energy, or we can say gain in gravitational potential energy. But in this case, helicopter is moving vertically upwards, and also helicopter is gaining speed. So in this case we will say the total work done by helicopter is equal to change in kinetic energy, means the gain in kinetic energy plus gain in GPE, and gain in GPE is equal to work done against gravity, is the work done against gravity. So this is the point you need to understand, work done against gravity. If the speed is constant, so the work done by helicopter is equal to gain in GPE, gain in gravitational potential energy, or you can say increase in gravitational potential energy. If the speed is also increasing, so the work done is equal to change in kinetic energy plus work done against gravity, change in kinetic energy. So if you look at given options, first one is telling us the work done on the helicopter by the force of gravity. No, because work is done by helicopter, so this option is not true. And also in this case speed is increasing, so this is not true. Total work done by the helicopter as it move upwards, that total work done is equal to the change in kinetic energy plus change in GPE. So this is not only the increase in GPE, so this option is also not correct. The work done by the helicopter against the force of gravity, yes, because that work done is gain in GPE, increase in GPE. So the answer for this question is C. The work done by the helicopter to increase speed, that is gain in kinetic energy. So they can ask you next time what is work done by the helicopter to increase speed, that is gain in kinetic energy. So the total work done by the helicopter, this is representing helicopter, so this is representing helicopter. So the work done by helicopter is used to increase its kinetic energy and also to do work against gravity, or simply we can say to increase GPE. So these are some beautiful points you need to understand. Work done by the helicopter to increase speed, this is increase in kinetic energy. I hope this one is clear to you. So the answer for this question is C. So we can also say this one gaining speed, so you can write on here, so gaining speed. Question 6 says an object moves with a velocity v. The kinetic energy of the object is doubled. Which of the following is an expression for the new velocity of the object? So simply we can start this question with kinetic energy. Kinetic energy is equal to 1/2 mv square. From here you can see that m by 2, this is constant. Mass of the object is not changing. So we can say kinetic energy over v square this is equal to 1/2 m, as this quantity is constant, so simply we can say the ratio between these two quantities remains constant. So we can write down here that kinetic energy over v square, this has to be equal to the new value of kinetic energy divided by new value of v. For this question, it is given to us new value of kinetic energy. New value is equal to 2 times Ke divided by, we have V nu square. From here we can simply cancel this Ke with this Ke, and we can write down from here that V nu square, this is equal to 2 times V square. Now if we take square root on both sides, we will get V nu, this is equal to root of 2 times V. So this is new value of V, and this is a beautiful way. Why I explain you this way? Because this method can be used to answer a lot of questions in physics. So that's the reason I use this one. Otherwise, simply I can say kinetic energy, this is equal to 1/2 mv square. If this kinetic energy is double, so this side also has to double. So that is possible if you have root of 2 v square. So from here I can say new value of v, so we can say v new, this is root of 2v, so we can simply write down like this. But this method is very useful. So the answer for this question has to be A. Question 7 says a power station provides an electrical output power of 2.1 gigawatts. The power station transfers thermal energy to the surroundings at a rate of 3.4 gigawatts. Which of the following gives the efficiency of the power station? So in this case we have power station, so this is simply, you can imagine, this one is the power station. So the useful work output, means the useful power output is given to us, that is equal to 2.1 gigawatts. So this is the useful P out, useful P out. And we also have dissipated power, or we can say the wasted power. So we have also wasted power converted into thermal energy and transferred to the surrounding. Power output, wasted power output, that is equal to 3.4 gigawatts. So what is the input to this one? Input, you need to understand, input has to be the sum of useful plus wasted. So this is our input. We need to calculate efficiency in this case, so this is symbol for efficiency, so this has to be P out useful, so this has to be useful over total P in, P input, P in. So we have useful, that is 2.1 divided by total, that is 3.4 plus 2.1. so the answer for this question has to be A. Most of the time students, they simply remember P out, but you have to find out useful P out. So this is the useful P out. So this is useful P out. Question 8 says a student applied a tensile force to a metal wire of length x and diameter d. The length of the wire increased by delta x. The student applied the same force to a second wire made of the same material. The length of the second wire increased by 2 delta x. Which row of the table could show the length and diameter of the second wire? For this question, it is given to us same force is applied. So the force is the same for two wires and same material. It means Young's modulus is the same, but spring constant is not same. K is different, but Young's modulus is the same because Young's modulus does not depend on dimensions of specimen. So we can start with Young's modulus. So we have Young's modulus is equal to stress over strain. So simply we can write down here, this is equal to stress over strain, and stress is equal to force over cross sectional area of the material divided by extension over original length. Now if we simplify this one, we will get here Fx divided by A times delta x. This is equal to Young's modulus. We can also write down the equation for cross sectional area. We can say this will be equal to pi by 4 d square times delta x. So here we have delta x. We can further simplify. We can write down y over f multiply by pi by 4. This will be equal to x divided by d square times delta x. But if you look at the right side, left side, in this side, these quantities are constant. So simply we can say this will be equal to constant, So here we have x over we have d square, and here we have delta x. So it simply means that the ratio between these quantities for two wires is constant. So we can write on here, we have for one wire x square, and this is divided by d square, and here we have delta x. For the second wire, we need to find out value of x new, and we need to find out value of d new, and we have value of extension, that is 2 times delta x. Now from here we can cancel out this delta x with this delta x, so we left with x over d square. So here we have, this is x new, and here we have d new square, and here we have 2. Now that's all. This is end of this question. Now simply what you need to do is you have to take these given values and you need to replace x new and d new with the given values. One set of values will satisfy this equation, and that is your answer. So let's try with the first one. So we have x new, that is equal to 0.5. So I can simply write down, this is 0.5 x divided by, we have 0.5 d square, and this is multiply by 2. Now from here you can see that 0.5 here we have, and here we have 2 0.5. So 1 0.5 will be cancelled. So what is left behind? We have x, and here we have 0.5 d square, and here we have 2. So if I rewrite this one, so it means this is x over, we have 1 by 2 d square, and here you have 2. So now you can see here, this is cancelled with this. So what is on the right side? Also x by d square. So it means this set of values, it satisfies this equation. So x new is 0.5x and d new is 0.5d. So our answer for this question is A. A beautiful way. Very nice question. Lovely question. So look at this question again. If you have any question, any doubts, please leave your questions in comments. And if this video is helpful, this video is helping you to improve your understanding of physics, and also if this video is giving you better understanding of these questions, please like and subscribe, because your encouragement is very important. With your encouragement, I will spare more time. I will make more useful and helpful videos for you. So please like and subscribe. You can also join Patreon if you need more help. Question 9 says, a box of weight W is suspended in equilibrium from a support by 2 ropes. The tensions in the 2 ropes are T1 and T2. Which of the following is a vector expression relating the forces acting on the box? In this question, it is given to you that the box is in equilibrium. So now simply you need to understand what is meaning of equilibrium. Meaning of equilibrium simply means that the vector sum of the forces has to be equal to 0. Vector sum. So simply we can say, if object is in equilibrium, vector sum of the forces acting on the object has to be equal to 0. Acting on the object has to be equal to 0. So simply we have three vectors here, so it means vector 1 t1 plus vector 2, this is t2, plus third vector, the sum has to be equal to 0. Vector sum of the forces on the object has to be equal to 0 if the object is in equilibrium. So the answer for this question has to be D. If your concept is clear, physics is just about concepts. If your concepts are clear, it's a fun to play with problems and solve problems. So try to clear your concepts. So the answer for this one is D. Question 10 says a box is pulled along the ground by a rope inclined at an angle of 40 degrees to the horizontal as shown in the figure. The tension in the rope is 30 newtons. The box is pulled 5 meters along the ground. Which of the following is the work done on the box? Work done on the box. We can also draw box here. So at this point we can draw, this one is the box. Box here. And box has been moved by 5 meters, so we can draw one line here, and the distance between these two lines is 5 meters. So this distance is 5 meters. So we can also label this one, this distance is 5 meters. Now we need to understand what is work done. Work done is force times displacement in direction of force. Displacement in direction of force. In direction of force. Or we can say work done is equal to component of force. So we can say component of force in direction of displacement. In direction of displacement, in direction of displacement, time we can say displacement, time displacement. So in this case, force has two components. One is the horizontal component, and this component is in direction of displacement, so we have to take this component. But this force also has a vertical component. So which component is in direction of displacement? This component, and this component is 30 cosine of 40 degrees. So simply we can write on here 30 cosine of 40 degrees multiplied by the displacement. Displacement is 5 meters. So if we solve this one, our final answer will be about 115 joules. So the answer for this question is B. So this is the answer. That's all for section 1. I have explained you all the questions about section 1. I tried my best to teach you and explain you this question in a simple way, so you can improve your conceptual understanding and also you can have better understanding of these questions. That's all for today's video, and I'll be uploading remaining questions from section 2 as soon as possible. Take care of yourself. See you in next video, and also very happy New Year. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2023 paper 1. In the last video, we have already discussed section 1, and today's lesson we will start from section 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 11 says the photograph shows a rocket. The rocket is launched vertically. The rocket's engines give a total upward thrust of 7.3 times 10 to 7 newtons. Calculate the initial acceleration of the rocket, and mass of the rocket is given to us. I have seen most of the time many students, they will do question like this. They will write down, first of all, F is equal to ma, then they will simply write down A is equal to F over m, and then they will take this value of thrust. They will write down here 7.3 times 10 to 7 divided by mass of the rocket, and then they will get some value of acceleration. But this is wrong. This is not the net force, because this one is wrong, and they will get the wrong answer because this is not net force. So this has to be the net force. So for Newton's second law, you need to understand this F is representing the resultant force. It's very important one. This is the resultant force. So in order to answer this question, first of all, we can sketch the free body diagram. So there are two forces acting on the rocket. One is the weight of the rocket. So this is mg, that is acting vertically downwards, and there is thrust force. So this one is thrust, and the value of thrust is given to us. We can also write on here, this one is the thrust, and value of thrust is 7.3 times 10 to 7, and value of weight we have 5.0 times 10 to 6 multiplied by 9.81. So we need to find out acceleration. So the acceleration will be equal to the net force, means the F net divided by mass of the system. So this is mass of the system. So very important one, this is mass of the system. So what is the net force in this case? Net force is thrust minus mg and divided by mass. So we have value of thrust here, that is 7.3 times 10 to 7 minus weight. Weight is 5.0 times 10 to 6 times 9.81 divided by the mass of the system. So the total mass of the rocket is given, that is equal to 5.0 times 10 to 6 kgs. If we solve this one, we will get value of acceleration. That will be equal to 4.78 meters per second per second. So this is our final answer, and this is initial acceleration. Now for this question has 3 marks. The first mark you will get if you have used this formula. If you have written this, you will get 1 mark, and the second mark you will get if you have used this formula. So you will get the second mark. So this is 1 mark here, 1 mark you will get here. So in the exam, always write down all the steps. Steps are very important. And the final mark you will get if you have got the right answer. So this is how these 3 marks will be awarded to you. So this is very common mistake. So this is very common mistake. Very common mistake. Part B says, give one reason why the acceleration will increase as the rocket rises. Little bit tricky question, but a practical question about rocket. So how we can answer this question? First of all, just imagine that we have a rocket. So this one is the rocket. So simply you can imagine this is rocket. So here is our rocket. You can also draw, this is head of the rocket. Head, and this rocket is filled with fuel. So it is filled with fuel. So this is the fuel inside. So this is the fuel inside this rocket. And we can also imagine that total mass of fuel and rocket, let's say here is capital M. Now when this rocket is rising, this rocket will use the fuel. And so we can redraw this rocket now. So you can simply imagine again. So this is rocket, and here we have head of the rocket. Now the mass of the fuel inside the rocket, this has decreased because fuel is used up by the rocket. So now we can imagine the total mass of rocket and the fuel is small m. So mass has been decreased. So if we calculate acceleration here, we will write down this will be equal to thrust minus weight. So here we have mg and this will be divided by capital M. And here if we calculate acceleration, this will be equal to thrust minus small mg divided by small m. Now if you compare these two equations, you will say this force, this one is smaller as compared with this one. So we can say, let's say this is F1, this is Fnet 1 and this is Fnet 2. So in this case Fnet 2 is greater than Fnet 1 because thrust is constant. And also if we compare the mass, this capital M with this small m, so small m is lower than capital M. So you can see in this case this increase, it means acceleration increases because Fnet will increase. As mass decreases, acceleration also increases. So it simply means that A2 and A1, if we compare, A2 will be much greater than A1. So that's reason acceleration will increase because mass will decrease. I hope this is clear to you. Let me show you the answer. In your answer, you can mention this point. You can simply say the mass of fuel decreases because fuel is used up. You can also say the resultant force increases because thrust is constant. And this question has only 1 mark. If you write down this point, you will get 1 mark. And if you write down this one, you will also get 1 mark. Question 12 says, a teacher demonstrated the principle of conservation of linear momentum using 2 gliders A and B and an A track. A has the same mass as B. A and B were initially stationary, then A was pushed gently towards B as shown in the figure. So this is representing the push. This arrow means the applied force on glider A. For part A, we need to state the principle of conservation of linear momentum. Principle of conservation of linear momentum simply tells us that for any isolated system, total momentum before collision is equal to total momentum after collision. Isolated system means that there is no net external force acting on the system. So far, principle of conservation of momentum, always we need to define a system. So in this case, our system consists of glider A and it consists of glider B, and there is no friction between gliders and A track. So if there is no friction and our system consists of glider A and glider B, momentum will remain constant because this is an isolated system and there is no any external force acting on the system. In this case, we are also ignoring air resistance. So simply we can say for any isolated system, total momentum before collision is equal to total momentum after collision, and this question has 2 marks. Let me show you how you can write down your answer. In your answer, you can mention these points. In the first point, you can say for an isolated system. If you write on this point, you will get 1 mark. And the second mark you will get if you have written total momentum before a collision is equal to total momentum after a collision, you will get the second mark. So this is how these 2 marks will be awarded. So it's very important you have to mention isolated system, as you can also say closed system. If you simply write down for a system, total momentum before a collision is equal to total momentum after a collision, that is not right. Your system has to be isolated system. Or you can say if no net external force is acting on the system, then total momentum is conserved. So this is how you can answer. Very nice question. Try to understand what exactly you are writing. Not just simply memorize and write down. You need to make sense what you're writing. This is real science. It's not magic, so you need to understand the reasoning. Part B says a magnet was attached to each glider. The gliders glided and stuck together. A data logger and sensor were used to record the velocity of A. The velocity recorded after the collision was half the velocity recorded before the collision. Deduce whether these results show that the law of conservation of linear momentum is obeyed. So this question is quite straightforward one, but there is a little problem with this question because they have mentioned there is a magnet attached with each glider. So you can simply imagine here is a magnet, so we can draw here. Let's say this is N pole of the magnet, this is N pole, and this is the S pole. Then here is another magnet is attached here. So this magnet has S pole here because they stick together. Then this is the N pole. Now you need to understand there will be attractive force between these two magnets. So they will be attracted. It means both of them they have to move. But in the question they are assuming is that this one stay at rest. Mean the initial velocity of this one is 0. This stay at rest until they collide. Mean its initial velocity is equal to 0 before collision. So we can say UB is equal to 0, and we can say this velocity, let's say this velocity is UA and this one is equal to V. We can also assume mass of this one is M, mass of this one is M. Now if we use conservation of momentum, so we can say momentum before, this has to be equal to momentum after. Momentum before we have M times V because the velocity of this one is V, so this velocity is V, mv, and momentum of this one is equal to 0, and final momentum, they stick together, so the total mass is m plus m, and they move together with the same velocity, and that is half of the initial velocity, means v by 2. So from here you can see that we have 2m times v by 2, so this 2 will be cancelled with this one, so we can see momentum is conserved. So it means momentum is conserved in this case. But there is little bit problem with this question. They have said there are two magnets on two gliders, so it means there will be attractive force, so there will be force on this one to the left, so this will also move. But they are simply telling us that velocity of A is v, and after collision velocity of A becomes half. So it simply means that this glider just stays at rest. So you need to understand when you do question, try to understand and try to picture in your mind, not just write down what you have memorized. Physics is about understanding. Physics is not about reciting something, so you have to develop your understanding in that way. So I hope this point is clear to you. If this is clear to you, this concept is clear, now we can simply answer this question. For the answer of this question, so simply we can say, you can write down these points. You can say momentum is mass time velocity, and after the collision the mass that is moving is double, means we have 2m. We can also sketch this one, so you can simply imagine this one is A, and here we have this is B, and after collision these two masses they stick together. So we have A here, we have B here, mass of this one is M, mass of this one is M, mass of this is M, so this is 2m. So the initial velocity of this one is V, and the final velocity of these two is V by 2. Mass is double than the original value. Because velocity is half, its original value of momentum remains the same, so the law is obeyed. So this is how you can answer. Is a easy question, not very difficult one, if your basic concept is clear. Second part says explain why the force of attraction between the two magnets did not affect this demonstration. So this question is just based on defining the system. In this case, we have defined our system consists of glider A and it consists of glider B. Now, if we draw the forces on these two gliders, force on glider A, this will be to the right because this is attractive force, and force on glider B, this one will be to the left. And these two forces, they have the same magnitude. So the vector sum of these two forces will be equal to 0. So we have in this case F plus F, and the vector sum of these two forces will be equal to 0, because we can say this is force on B and this is force on A, because the force on A is equal to the negative of force on B, because these forces, they have opposite direction. So the resultant force on the system in this case is equal to 0. So simply we can say F net on the system is equal to 0, because these two forces are internal forces. These are internal forces. So that's the reason in this case momentum is conserved, because there is no net external force on the system, and these two magnetic forces, these are internal forces, and the resultant force of these two is equal to 0. So this is how you can answer. So let me show you the answer. In your answer you can mention these points. First of all, you can say the gliders accelerate in opposite directions because the forces are equal in size and opposite in direction. Mean direction of acceleration and direction of resultant force on this glider has to be the same. So this is acceleration of B and this is direction of acceleration of A. So acceleration of A. So the resultant force on the system is equal to 0. You can also say in terms of forces, you no need to talk about acceleration. You can simply say force on A and force on B, they have equal magnitude but they are in opposite directions. So the resultant force is equal to 0. So that's the reason this demonstration is not effective, because these two forces are internal forces. So in this case, momentum of the system is conserved. So this is how you can answer. Question 13 says tennis players can practice using a tennis ball machine. The machine projects balls horizontally from a height of 2.54 meters as shown in the figure. For part A1, show that the time taken for a ball to reach the ground is about 0.7 seconds. If you look at this question, for this question we don't have any information about horizontal motion, so we have to look at the vertical motion. For vertical motion, we have the initial vertical velocity that is equal to 0. So in this case we have to consider vertical motion because we don't have enough information about horizontal motion. And for this question we have the vertical displacement SV that is equal to 2.54 meters, and also we have vertical acceleration that is equal to 9.81 meters per second We need to find out value of time. So this is what we need to find out. We need to find out value of time. So how we can find out value of time? So simply we can use S is equal to UT plus 1/2 AT square. Acceleration is constant, so that's the reason we can use this one. Acceleration is only due to gravity. In this case we are ignoring air resistance. Now simply we need to plug in values. Initial velocity is equal to 0, so it means this term will be equal to 0. So simply we left with S, and that is equal to 1/2 AT square. We need to find out value of t, so we can simply write down t will be equal to 2s divided by a and the square root of this, and we can plug in values and we can find the answer. So in this case you have to define one direction as positive. So in this case I'll be defining down is positive because these two quantities will be positive. Even if I take up is positive, negative will be cancelled with negative. For simplicity I'm taking down is positive. If I take down is positive, this displacement is downwards, it means this displacement is positive and acceleration is also positive. So I can simply plug in values here. This is 2 times 2.54 divided by 9.81, and if we solve we can find the final answer. That will be equal to 0.72 seconds. So this is how we can answer. This question has 2 marks. The first mark, if you have used this formula, you will get 1 mark. Then the second mark you will get if you have got the right answer. Second part says the ball lands on the ground at a horizontal distance of 17.89 meters from the machine. Calculate the velocity of the ball as it is projected from the machine. So this question is simply telling us that this distance, the horizontal displacement from the machine, this is equal to 17.89. So this is 17.89. It's very important if you label this one. We need to find out the initial velocity, means we need to find out value of u. This is value of ux, horizontal velocity. As there is no force along horizontal, so simply we can say s will be equal to ut plus 1/2 at square. As there is no force along horizontal, it means that acceleration will be equal to 0. So simply we left with s is equal to u times t, and we have already calculated value of time in part A. T was equal to 0.72 seconds, and we have value of s, so we can find out value of u, and this is over ux. We are talking about horizontal motion, so ux will be equal to sx divided by time taken. So sx is 17.89 meters, and this is divided by time, that is 0.72 seconds. So the answer for this question will be equal to 24.8 meters per second. So this is how you need to answer this question, and this question has 2 marks. The first mark you will get if you have written this formula, and the second mark you will get if you have got the right answer. Part B says the initial velocity of the ball as it is projected from the machine can be increased. Means this component of velocity can be increased. We can simply say this is ux. Explain how increasing the initial velocity would affect the angle at which the ball hits the ground. Means angle at this point. So first of all, simply we can imagine the initial velocity, means horizontal component of velocity, is equal to this one. So we can simply draw one small arrow here. This is representing initial horizontal velocity. Horizontal velocity will not change at this point and at this point, because this velocity and this velocity has to be the same. In these two component of velocity has to be the same, because there is no acceleration, there is no force along horizontal. We are ignoring a resistance in this case. So this is at one instant we can say horizontal component of velocity is equal to this, and at that instant we can also consider vertical component of velocity. So let's say this is vertical component of velocity. We can find the resultant of these two. So simply we can draw this arrow here, and we can find out the resultant of these two, means the resultant velocity when it strikes the ground. So the resultant velocity in this case simply will be equal to this. So this is representing resultant velocity. We can say this is vertical component of velocity, we can say Vy, and this one is horizontal component of velocity, so this is Vx, and this is the final velocity when horizontal component of velocity is equal to this, or you can say when initial velocity is equal to this one. An angle with horizontal, we can say this angle is theta. This angle is theta. Now in this case, for this question we need to understand, is this velocity changing or not? This velocity simply we can find out for vertical motion. 2as is equal to v square minus u square. For this question it is given to us that initial vertical velocity is equal to 0, because it is just projected horizontally, so this one is equal to 0. So we can write down v square in this case will be equal to 2as. A is constant, s is also constant. If we keep s constant, it means this v also remain constant. So it means this component of velocity will not change. So this is the first thing you need to understand. Vertical component of velocity is not changing. Now simply we need to look at horizontal component of velocity. So if I increase this component, just let's make it bigger one. If I increase this much, what is the new value of angle now? So now we can find out the new value of the velocity. So this vector you can draw here, I mean this is the vertical component of velocity, and the resultant velocity in this case, we can take this arrow, we can redraw this one, so we can redraw here, so this is here. Now we can draw the final velocity at this point. So I'll be using different colors, so let me use pink color for this one. So I can draw this here, this one here. Now if you look at the angle, so the initial angle we have this one, so this was our first angle, so this was our first angle, you can see here, and our new angle is this one. So I can say this is theta 1, this is theta 2. Now you can see in this case theta 2 is smaller than theta 1, so it means angle decreases. So we can simply say angle decreases in this case. Why angle decreases? Because horizontal component increases. So that's the reason angle with horizontal decreases. We can also understand this one with the help of tangent of theta. So we can say tangent of theta. Tangent of theta will be equal to Vy divided by Vx. So from here we can say theta will be equal to tangent inverse Vy divided by Vx. So in this case this component remains same. So if this component increase, angle will go down, angle will decrease. So these are the points you need to understand. In a simple language, one point you need to understand, vertical component of velocity remains same, so this component remains same. This is what you need to write down in your answer, this remains same. The second point you need to understand, as this component increases, angle will decrease. Angle will decrease, you can also use this equation, you can show this one. And this question has 3 marks, so if you write down these 3 points, you will get 3 marks. So that's all what you need to understand. I try to explain you in a simpler language and in a beautiful way, so it makes sense to you. I hope this question makes sense to you. This question is a bit tricky one. Now let me show you the final answer, how you can write down your final answer. In your final answer, you can mention these points. So I will clear this ink so you can see the final answer. In the final answer, we can talk about these points. The first point you can say horizontal component of velocity is larger, has increased. Vertical component of velocity is not effective, remains same. So tangent of theta is equal to this. So theta decreases. So this is how you can answer. That's all for today's lesson. I hope this video was helpful. If this was helpful, please like and subscribe, and also leave some comments in comment section. And also if you need more help and you want to support this channel, please join Patreon. See you in next video. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from October-November 2023 paper 1. In the last 2 videos, we have already discussed from question 1 to question 13. And today's lesson, we will start from question number 14, and we will try to cover all remaining questions from this paper. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 14 says, a student exercises by lifting weights attached to a machine. The machine has a cable as shown in the photograph. The cable passes through a handle and is connected to a weight. There is tension capital T in the cable. The angle between the two sides of the cable is 60 degrees as shown in the diagram. Part A says a person keeps the cable stationary by applying a force of 121 newtons. Determine the magnitude of the tension in the cable using a scaled vector diagram. So in this case, tension in the cable is this way. So this one is the tension. So here is also tension in the cable, and person has to pull in this direction. So person is applying force along this direction. So we can simply, rough idea is that force is in this direction. Now if you look at this diagram, it is given to us that the angle between tension is equal to 60 degrees. We can redraw this one. We can redraw, let's say we have one vector here, this is t. We can label this one is t, and we have another vector, this is also t. It is given to us the angle between these two vectors. This angle is 60 degrees. 60 degrees. We can complete this parallelogram and we can try to find out the angle between this vector, the head of this vector, and the tail of this vector. We can do this one by two different methods. One is the parallelogram we can use. So in this case, I can take this vector, I can place here this vector, and the second vector we can draw from here. So this one is our second vector, and also we can draw a dotted line here. So this is the dotted line. So this angle we have, this one was 60 degrees. So what is this angle? I hope you will simply say this angle is 120 degrees. So the angle between the head of first vector and the tail of the second vector is 120 degrees. So this is one way you can find the angle. Now let me explain you the second way. The second way is we can simply draw one vector here. So this is our one vector, and the second vector we have, that one is here, and angle between these two vectors is given. Very important point, basic concept, but I'm quite confident most of you struggle with this concept. So this angle is given to us, this is 60 degrees. So this is t and this one is t. Now a beautiful way is I can take this vector, I can just move this one in backward direction. I can take this vector simply, actually it's very hard to select this one. I can simply imagine, you can just imagine, I can take a different color. I can draw here. So this is our vector. Now I take this vector in backward direction. I move this one in backward direction. So means I move this vector to this place. Now if I ask you, what is this angle? I hope you will say this is 120 degrees. So this is the first thing you need to understand, is a basic concept. If you are struggling with this one, you can follow any one method to find the angle between head of first vector and the tail of next vector. So now we have the angle between head of first vector and tail of second vector. So this angle is 120 degrees. Now for this question, it is given to us that force is 121. Now the force, you need to understand the force. So the resultant, as this is in equilibrium, it is stationary. It is given to us, this is stationary. It simply means that the resultant of these two vectors, we can draw the resultant using red color, means the resultant of these two vectors is this one. So the force has to be in the opposite direction to balance this. So the force has to be along this direction. And this force is 121 newtons. So it means the resultant of these two vectors is also 121 newtons. So we have to draw scaled vector diagram. So this is over one vector, this is over another vector. So this vector, it means you can just move here. So resultant has to be 0. So this one you will move here. So that will be the final answer. Means the final shape has to be like this. You have t here, and the other vector, this one is t, this one is here, and the force has to be in this direction. So this is how we need to sketch. I hope now you have the idea about this one. So this angle we have found, this angle is 120 degrees. If this angle is 120 and these two sides are the same, so it means this angle has to be 30 degrees and this also has to be 30 degrees, because the sum of interior angles of a triangle is equal to 180 degrees. So this angle is 30 degrees, this angle is 30 degrees. We have these two vectors, they have the same magnitude, and we have the magnitude of this force. Until now, we have concepts we need to answer this question. Let's use our this understanding and try to answer the question. So the first thing we need to do is we need scale first of all. So we have F, in this case F is equal to 121. So we can simply say 20 newtons is representing 1 centimeter. 20 Newton is representing 1 centimeter. So this force we have 121. So this is roughly 6 centimeters. So we can say this is roughly 6 centimeters. About, if you want to be very precise and accurate, you can use the exact number. But if you use 6 centimeters, that will be acceptable. So it means that this vector has to be 6 centimeters long, and it should make angle of 30 degrees with horizontal. So now we need to draw angle. So let me try and explain you how you can draw the angle. So I'll grab this protractor. This is protractor. So we can grab this one. So let me clear everything at the background. We need to draw angle of 30 degrees. Angle of 30 degrees. So first of all, we can start with this. So this is our angle of 30 degrees. So we can place this one here. So we have more space. So this one here. So this angle is 30 degrees with horizontal. So we can draw a line here. So I'll simply sketch a line here. So we need to sketch line here. So this line is at angle of 30 degrees. So this is how you can sketch the line. We can sketch the line, and I can just place this one here. This line has to be 6 centimeters long. 6 centimeters long. So I will draw another line here about 6 centimeters long. So this has to be 6 centimeters long. So this is about 6 centimeters. And we don't need this line. The previous one, I can clear this. So this is at angle of 30 degrees. And the length of this one, we can also write down the length of this, because I just want to explain you in a better way so you understand one in a nicer way. So this one is 6 centimeters long. Now we need to draw T, tension. So for T, actually we need to calculate value of T. We have already discussed that we have this triangle. So this is our previous triangle. We have said this angle is 120 degrees, this angle is 30 degrees, this angle is 30 degrees, and the force is 121 Newton. So now we need to find out value of T. So value of T we can find out using cosine law. So we can simply use cosine law. So we can use between these two sides, mean this side and this side. So we can say in this case T square will be equal to 121 square plus T square minus 2 times 121 times T times cosine of angle between these two sides, that is 30 degrees. So from here you can see this T square, this will be cancelled with this one. So if you solve for T, you will get, in this case, value of T will be equal to 69.85 newtons. Based on our scale, we have around 70 newtons. This one has to be equal to 3.5 centimeters. 3.5 centimeters. Now we can draw a line. We can draw a line from here that has to be 3.5 centimeters. Let me use different color. So we can draw the line that has to be 3.5 centimeters. The line actually has to start from this point. So this has to be 3.5. So this is 3.5. And from here again it has to be 3.5 because these two lines, they have the same length, because they have the same magnitude, value of t. So this is how you need to draw the triangle. Now we can label. So this angle is 30 degrees. This angle we have mentioned, this was 120 degrees, and this angle also has to be 30 degrees. So vector, so you have to draw these arrows. So this is value of t. T is equal to, in this case, 69.85, mean this is about 70 newtons, and this is also about 70 newtons. So this is the final, and this arrow is very important, this arrow. So this is in the opposite direction of resultant of t's. So this is how you need to sketch. You also need to add arrow here. We have discussed this one in detail. I hope this one is clear to you. A nice question. If you can master this question, a lot of questions about vector diagram you can answer by yourself. And I'm hoping this one is clear to you. You can see this angle is about 60 degrees. I mean, this angle is about 60 degrees. So this angle is 120 degrees. So this is 120. So this is how you can answer. I hope this is clear to you. Part B says the cable is attached to a 150 newtons weight. Each time the person pulls the handle, weight moves up a vertical distance of 0.25 meters. The weight returns to its original position when the handle is released. The person exercises by pulling and releasing the handle. They do this 90 times in 120 seconds. The exercise machine displays the average power of the person as 35 watts. Deduce whether the power displayed by the machine is consistent with this data. So data in this case is given to us. So simply we can imagine, first of all, this one is the weight. So you can simply imagine this one is the weight. This is 150 newtons. And person lift this weight. So we can also draw here. The person lift this weight. So this distance we have lift by vertical distance, that is equal to 0.25 meters. Lift by vertical distance of 0.25 meters. And then person release the handle, weight come back. Then person again lift this one. Then release the handle, it come back. Then lift this one. And person repeat this one 90 times in 120 seconds. So in this case we can find out, first of all, the work done. So the work done will be equal to force. The person is moving with constant speed. So this is the assumption. Person is lifting this weight with constant speed. So constant speed, it simply means that the force on this one, the force applied upward, this force is also 150 newtons. So 150 newtons on the weight is up, and the weight is acting down. Weight is 150 newtons. So work done will be equal to force time displacement in direction of force. So the work done by person is equal to force applied by person time the displacement in direction of force applied by person. So we have force applied by person, that is 150 newtons, and displacement is 0.25. So we can solve this one. We will get 37.5 newtons. So this is one time is the work done by the person. We need to calculate power. So power will be equal to the total work done by the person. So we can say W total work done by person divided by total time taken. So this is the T total. Total work done. In one time the person do work equal to 37.5 joules. So this is joules, is work done. So this is 37.5 joules. And person repeat this one for 90 times. So we have to multiply by 90, and this is done in 120 seconds. So if we solve this one, we will get 28.1 watts. As in this case, 28.1 watt, this is less than 35 watts. So it means that it is not consistent with the machine data. So we can say it is not consistent with machine data. So this is how you need to answer. So if you write down these steps for this question, you will get theory marks. A nice question. There are some important concepts you need to understand. Work done is the product of the force and displacement in direction of force. So this is how we can answer. Question 15 says the photograph shows a ladder that a person can use to climb into the roof space of a building. When not in use, the ladder is stored in the roof space and the opening to the roof space is covered by a board. The board is hinged to the ceiling at one end. It is also given to us the ladder is attached to the board by a rail as shown below. A small block prevents the board from rotating into the roof space. Far part A state what is meant by the center of gravity of an object. Center of gravity of an object is a very important point, and it's an imaginary point where if we apply one single force we can balance the object. So if we look at this marker and if I need to find the center of gravity of this one, I will place my finger under this one and I will move. At one point, if I just apply the single force, I can balance this one. And that point where I'm applying force with the help of my finger in upward direction, that point is center of gravity. That point is where whole weight of the body may be considered to act. We can consider at single point at center of gravity, means at that imaginary single point whole weight of the body is acting. So that's the reason if we just apply single force we can balance this one. And in the exam, if they ask you to explain or they ask you to state what is meant by center of mass, simply you need to say a point where whole mass of the body may be considered to act. When the object is horizontal, center of gravity and center of mass almost the same. They lie at the same point. But when object is vertical, center of mass and center of gravity will be different. So center of mass and center of gravity, they are very similar. So for this question we need to define center of gravity. Center of gravity, this is how you can define, this is how you can write down the answer. In your final exam, you can simply say it is an imaginary point at which whole weight of the body may be considered to act. In the exam, if they ask you what is center of mass, we can simply then replace the weight with mass. So this is how you can also define center of mass. Center of mass and center of gravity, they play very important role in design. When we design something, these 2 points are very important to consider. So we need to consider the center of mass of the object when we design any structure. Part B says the weight of the board and rail is 50 newtons. The weight acts at a distance of 0.45 meters from the hinge as shown in the figure. The total length of the ladder is 2.70 meters with 0.85 meters to the left of the hinge. The weight of the ladder is 54 newtons. Assume the ladder is uniform. Explain why the board and ladder remain in the position shown in the figure. Why they remain in equilibrium. So for this question we need to understand hinge is here. So this is the hinge, this is our pivot point. In a simple language we can say this is the pivot. So there is moment due to this force, 50 Newton force, and 50 Newton force is the weight of board and the rail. So there is moment due to this force, and this ladder is uniform, means the center of gravity, so simply we can say the center of mass of the ladder is at its geometric midpoint. You can say geometric midpoint. So this is meaning of uniform. Geometric midpoint means at the midpoint. So midpoint will be somewhere here. So in this case simply we need to find the moment. So if we draw the arrow here, so there is moment due to the weight of the ladder. So we can draw here. And this distance we need to find out. Distance between center of mass of the ladder and between the pivot, and this distance will be equal to, let's say this distance is x, so x will be equal to 2.70 divided by 2 minus this distance. So this is 0.85, means 2.70 divided by 2 means we got this midpoint. Now we need to find this distance. So 2.70 by 2 is the distance from this point to the midpoint. Now we need to find out x, so we have to subtract this one. So if we subtract this one, we will get 0.50 meters. So means x is equal to 0.50. So moment due to this force, this is counterclockwise. Moment due to the ladder, this is clockwise. So this is clockwise, this is counterclockwise. So we can calculate clockwise moment first of all. Clockwise moment, that is due to ladder. So clockwise moment in this case will be equal to weight of the ladder, that is 54. So we have 54 newtons multiplied by distance, that is 0.5. So we will simply get 27.0 newtons meter, and this one is clockwise moment. Due to this is anti-clockwise moment, so we can say anti-clockwise moment. So we can write on here, we have anti-clockwise moment. So anti-clockwise moment, this will be equal to the force 50 newtons, and the distance between these two is 0.45, mean the distance from the pivot. And if we multiply this one, we will get that is 22.5 newtons meter, and this one is counterclockwise. For this question, it is given to us this ladder remain in the position. It means this one is stationary. You can also say this is in equilibrium. It means clockwise moment has to be equal to counterclockwise moment. Clockwise moment we have, that is 27.0 newton meters, and the counterclockwise moment we have, that is 22.5 newtons meter, and this one is less. It means some moment is due to the board. So we have the board here, this one is the board, so there is a force by the board. So we can say there is also moment due to the block. So this moment is due to block. So in this case, simply we will say the block causes moment, or we can say block exerted force causes moment. So that's reason. Ladder is in equilibrium. So we can say ladder is in equilibrium, or we can say it remains in its position. Ladder is in equilibrium. So this is how we can answer these points. You need to understand. Simply you need to calculate the net moment, as there is some net moment, but this is in equilibrium. It means that missing moment has to be provided by the block, because net moment in this case is clockwise, so the block has to exert counterclockwise moment to balance the net moment. So this is how we can approach this question. Part 2 says a downward force is required to rotate the board away from the block. This force is applied 0.80 meters from the hinge. Determine the magnitude of this force. In the last part we have already discussed net moment is balanced by block. Now simply we need to calculate value of that resultant, or we can say that net moment, and that moment is provided by the block. So simply we can say resultant moment will be equal to 27.0, this is clockwise moment, minus counterclockwise moment, that was 22.5 newtons. So this is counterclockwise. So in this case, resultant moment we will get, that will be equal to 4.5 newton meters, and this moment is clockwise. To balance this one, we can say the moment by the block, moment due to block, that moment has to be equal to 4.5 newtons meter, but this one has to be counterclockwise moment. Now we have value of the moment, so we have moment that is equal to 4.5 newtons meter, and the distance from the hinge is given, that is 0.80 meters. So we need to find out the force, magnitude of the force. So from here we can simply say force will be equal to 4.5 divided by 0.80 meters. If we solve this one, we will get 5.63 newtons. So simply here is a force, this force is here, and this one is the hinge, the distance we have. We need to find out the force. Moment due to force we also have. So simply we can use this one and we can find the value of the force. This question has 2 marks. So if you have used this formula, means moment is equal to Fx, this one you will get 1 mark, and if you have got the right answer you will get 2 marks. Question 16 says a steel object is held by an electromagnet. The magnetic force prevents the steel object falling. For part A, state 2 reasons why weight of the object and the force from the electromagnet are not a Newton third law pair forces. So first of all, we need to understand a little bit about Newton third law pair. Newton third law pair, because your concept first of all has to be clear. So the first thing, Newton third law pair, they should have the same magnitude of force, same magnitude. The pair forces, they should have the same magnitude and opposite direction. So they should have opposite direction, and there should be two forces of the same type. Very important. Student mostly simply remember this one, same magnitude, opposite direction, but that is not the whole story. Also, forces must be of the same type, and they should be acting on two different objects. Acting on two different objects mean not acting on the same object, acting on different objects. And also these forces act for the same time. So these are the things you need to understand for Newton third law pair forces. They should have these characteristics, or we can say these are conditions for two forces to form Newton third law pair. Now if you look at the given forces, in this case we have two forces. It is given to us this steel, this ball bearing, this one is not falling. So we have two forces acting on this one. So we can say one force is the weight of this that is acting down. So this is mg, this is force due to gravity, and there is magnetic force on this one that is acting upwards. So we can say this one is Fb. This is the magnetic force, and these two forces, they are equal in magnitude and opposite in direction. So it means this condition, these two conditions are satisfied. But these two forces, they are not of the same type, so this condition is not satisfied. Need to act on two different objects. They are acting on the same object, so it means this condition is also not satisfied. So these two forces, they do not form Newton third law pair, because they are different type of forces and they are acting on the same object. So that's all what you need to understand. So now let me show you the answer. So simply this is how you can write down your answer. You can say act on the same object and they are different type of forces. This question has 2 marks, so if you write on these 2 points you will get 2 marks. I hope these videos are helping you. If this video is helpful, or the videos you have watched on the channel, please like and subscribe, and also leave some comments in comment section, because your encouragement is very important. If you need more help and also you wanna support the channel, you can join Patreon. Part B says the electromagnet is suspended from a support by a steel cable as shown in the figure. When the object is suspended, the strain in the cable is 3.0 times 10 to minus 4. Calculate the Young's modulus of the steel in the cable. Cross-sectional area of the cable is given to us. Unstretched length of the cable is given, and stiffness of the cable is given to us. So simply we need to calculate Young's modulus. This question is a little bit tricky one. So how we can start this? So we can write down first of all formula for Young's modulus. Young's modulus is equal to stress over strain, mean the ratio between these two quantities, and stress is force over cross-sectional area and strain is delta L by L, or we can say delta X by X. So I'll be using here delta L by L. So if we rearrange this one, so we will get this is F L divided by A times delta L. For this question we have value of A, so this is value of A we have here. We have value of L, so this is value of L, but we don't have value of delta L, but we have the value of strain. So first of all, we can calculate delta L. Delta L will be equal to strain times the original length L naught. So this is L naught original. Now we have value of strain that is given here, so we can say this is 3.0 times 10 to minus 4 multiplied by L naught, that is 3.8. so we will get 1.14 times 10 to minus 3 meters. So this is value of delta L. Now we have value of delta L, we have value of A, we have value of L naught. So we need to find out value of F. But we have stiffness constant, means we have K, that is equal to F divided by delta L. So we need to find out F. From here we can say F will be equal to K times delta L. So we have K, stiffness constant, that is 2.8 times 10 to 7 newtons per meter, and value of delta L we have just calculated, that is 1.14 times 10 to minus 3 meters. So if we solve this one, we will get force is equal to 3.19 times 10 to 4 newtons. So this is value of force. Now we have all the quantities. Now simply we need to plug in and we can find the value of Young's modulus. So finally we can say Young's modulus is equal to F L naught divided by A times delta L. So value of force we have, that is 3.19 times 10 to 4. Value of L naught we have, so this is over L naught, so, and this is 3.8. we have value of A, cross sectional area, that is 5.1 times 10 to minus 4, and we have value of delta L, that is 1.14 times 10 to minus 3. Now if we solve this one, we will get value of Young's modulus is 2.09 times 10 to 11 pascals. So it is very important to remember that Young's modulus order of magnitude is about 10 to 11. Young's modulus of steel is about 10 to 11 pascals. So next time if you do calculation, you got very small answer or you got very big answer, so it means that is not right. So it's very important to remember value of Young's modulus for steel. It is in the range of 10 to 11, means order of magnitude is 10 to 11 pascals. So this is how you can answer. If you have done these steps for this question, you will get 4 marks. This question is not difficult, just a little bit tricky. You need to understand how to play with these equations. I mean, how to get value of F, how to get value of delta L. So that is only tricky part. We have value of L naught is given. So for this question, only tricky part is you need to get value of F and value of delta L. We have the stiffness constant, so this is stiffness we have. Delta L we can find because we have strain, we have L naught. Second part says the force extension graph for the steel cable is shown below. When the electromagnet is switched off, the steel object falls. A student states that the change in elastic strain energy stored in the cable will be transferred to the gravitational potential energy of the electromagnet. Discuss the student's statement. You should add to the force extension graph as part of your discussion. So very conceptual question and also a beautiful question. Let's try to answer this one step by step. First of all, let's try to understand the statement of the student. Student is simply saying when this steel object falls, the magnet, so we can draw this one is the magnet. This magnet will move up. So we can also extend the line here. So this is the line here, and this magnet moves up. So we can, for simplicity, we can say this is the change in height. So this is the change in height. We can say this is delta H. So in this case, can we say that the change in gravitational potential energy, mean the gain in gravitational potential energy, that one will be equal to the mass of this electromagnet times G times delta H. And the student is saying is that loss in EPE is saying simply that loss in elastic potential energy is equal to delta GPE, or we can say is saying gain in GPE. Gain in GPE. So this is what student is saying. Now we need to discuss, is the statement of the student, is it valid or not? Mean, is it correct or not correct? So first of all, we can draw the line here. What this area under this line is representing, we can say this area is representing elastic potential energy, and this is the initial elastic potential energy, initial EPE. This whole area is representing initial EPE. Now it is given to us this steel object falls. When this steel object falls, then only weight of electromagnet is acting downwards, so that is equal to the tension in the string. So we can take any point here. So let's say at this point. So this is representing weight of electromagnet. So we can say now we have only weight of electromagnet. So this is weight of electromagnet. Weight of electromagnet. We can also draw the line here. So we can draw one dotted line here. Now in this case, area under this one, this is representing the final EPE. So this is representing final EPE. So this area is final elastic potential energy. So the change is equal to this one. So change is equal to this area. Let me use pink color, or let me use orange color. So this area is change in EPE. So simply we can use orange color. So this area, this is change in EP. Orange color, this is representing change in EP. So this is delta EPE, change in EPE. Now we need to find out what is the change. So let me draw here. So the loss in EPE, in this case, we have, this is the loss in EPE. So we can also clear this one so it looks more real. So this is the change in EP. So this is change in EPE. We can also divide this one into two parts. We can draw this line here. This line here. Now in this case, what is the change in GP? Means the gain in GP. Gain in GPE is equal to the weight of this one times the height. So it simply means that is equal to decrease in extension. So decrease in extension in this case, this is equal to delta H. So this one is the delta H. So force is constant, we have delta H, so it means this area now we can use a different color, maybe we can use black color. So this area is change in GPE, means the gain in GPE is this area. So this is gain in GPE. So in this case, simply we can draw here. So gain in GPE, we have this one. So this is gain in GPE. Gain in GPE. So this one is gain in GPE. You can label this one on the graph. So this one we can say change in EPE. So you can also write down this one on the graph. So this is change in EPE. In this case, we can simply see that delta EPE, this one is greater than delta GPE. So it means that the statement of student is not correct. So this is what you need to write down for the answer of this question. I hope this makes sense to you. Now I will simply clear this one and I will Let me use different colors simply on the top of this. So this one we can say this is delta GPE. You can simply label this one. This is delta GPE, and this total is delta EPE, and this area is initial EPE, and this area is final EPE. So these are the points you need to understand. Very nice question. If you don't understand one time, stop the video, give some time, try to picture in your mind, and then watch the video again. It will make sense to you. Now let me show you the answer, how you can write down your final answer. So this is how you can write on your final answer. You can also see this figure is here actually. Also these things are written on this one. You can also check this one, but I have explained you this in detail. So these are the points we have to mention in our final answer. You can simply say area under graph is elastic strain energy. As we discussed, this total area, this is the initial elastic potential energy. As weight of electromagnet is still exerted on the cable after object, so change in elastic potential energy is equal to area under graph between total weight and weight of electromagnet only. So this area means this one, this is equal to the change in EPE we have already discussed, and change in GP of electromagnet is weight of electromagnet times change in extension as we discuss here. So change in here. So the change in elastic strain energy is greater than change in GPE of the electromagnet. So we have discussed that point here. A beautiful question. Watch this one more than one time. It will make very clear sense to you. And also, if this is helpful, please like and subscribe, and also leave some comments in comment section. And also, if you need more help and you want to support this channel, join Patreon, and the link for Patreon you can find in the description of this video. Question 17 part A says, state what is meant by upthrust. Upthrust simply we can understand with the help of this container. Imagine that we have this container, and inside this container we have a fluid. I mean, it can be gas, it can be liquid. And if we place a ball inside this fluid, this ball will experience an upward force. So there will be an upward force on this ball, and that upward force we call is upthrust, and that is due to displacement of the fluid. So this is how simply we can state upthrust. Let me show you the answer, how you can write down your answer. In your answer you can mention this point and you will get 1 mark. So simply you can say an upward force caused by the displacement of fluid by an object, and if you have written this one you will get 1 mark. Part B1 says, when the balloon is released, the initial upward acceleration is 4.80 meters per second per second. Show that the weight of the balloon and equipment is 13 newtons. Volume of balloon and equipment is given to us, and density of air at ground level is also given to us. It is given to us this accelerate in upward direction. So first of all we can draw free body diagram. The force acting downward direction is the weight of equipment and balloon, and there is upward force acting in upward direction. We can use letter U for this one. It is given to us, it is accelerating in upward direction, so we can say this is direction of acceleration, and direction of net force always in direction of acceleration, mean direction of acceleration and resultant force always in same direction. Now simply we can use Newton's second law equation. F net is equal to ma. F net is equal to ma. So we can say ma, this has to be equal to the upthrust. We can say here we have upthrust minus weight. So we can write down minus weight. So this is the net force. So we can write down ma. This is density of the fluid times volume of fluid displaced times G minus mg. So we can rearrange this one. We can write down ma plus mg. This will be equal to density of fluid times volume of fluid displaced times G. From here we can find out value of m first of all. So we can take m common, and so we have A plus G. This is equal to rho Vg. So this is density of fluid, this is volume of fluid displaced. Now from here we can write down here, so we can say m will be equal to rho Vg. So this is density of fluid, volume of fluid divided by A plus G. Now we can plug in values. Density of fluid is 1.23 and volume of fluid displaced is equal to 1.63, and times G we have 9.81, and this is divided by A, that is equal to 4.80 plus 9.81. Now if we simplify this one, we can find the value of the mass. Value of the mass is 1.346 kgs. We need to find out weight. So we need to find out value of weight. So the W simply will be equal to m times G. So we have m 1.346 kgs multiplied by 9.81. So we will get, this is 13.20 newtons. So up to 2SF, this is equal to 13 newtons. Up to 2SF, this is equal to 13 newtons. So this is how we can answer this question. So the better way is, first of all, write down in a proper form. So get expression for the mass, then plug in values, and then you can calculate weight. Second part says the graph shows how the density of air decreases with height above the ground. The scientists want to make measurements at a height of 25 kilometers where the balloon would stop rising. The balloon will expand as it rises and will burst if its volume exceeds 50 cubic meters. Deduce whether the balloon could support the equipment at a height of 25 kilometers without bursting. So we have condition, the volume of the balloon. Volume of balloon should be less than 50 cubic meters. If it exceeds, then balloon will burst. So this is the condition. And it is also given to us, it stopped rising at 25 kilometers. So it means that upward force, so we can draw the free body diagram. We can say the up thrust, this is equal to weight. So it simply means that up thrust, this is equal to 13.2 newtons. We have already calculated weight of equipment and balloon. And up thrust is equal to density of fluid times volume of fluid displaced times G. From here we can find out volume of fluid displaced. This will be equal to 13.2 divided by density at 25 kilometers. So we have 20, so this is 21, 22, 23, 24, 25. So 25 is about here. And we can read from the y-axis, so we can read from here. And this value is about 0.05. So we have density that is equal to 0.05. So here we have 9.81. This is value of G. And if we solve this one, we will get volume of fluid displaced that is equal to 26.9 cubic meters. And this is volume of fluid displaced. But volume of fluid displaced is equal to volume of the balloon and volume of equipment. So in this case, we are assuming volume of equipment is negligible. So then simply we can say as 26.9, this one is smaller than 50 cubic meters. So it can make, so we can say yes, it can support. So we can say yes, it can support. It can support. Because this is volume of fluid displaced, and if we consider volume of equipment, so volume of balloon even will be smaller than this value. So that's the reason balloon will not burst and it can support the equipment at 25 kilometers. A practical question, beautiful question. I hope this one is clear to you. This question has 4 marks. 4 marks. So if you have written these points, you will get 4 marks. Part C says a balloon made of a strong material will rise and eventually stop expanding. It will continue to rise until it reaches a maximum height. Explain how and why the velocity of the balloon changes from release until it reaches its maximum height. Ignore the effects of drag force. So in this case, we can ignore drag forces. So we need to discuss the velocity from point of release to the maximum height. So we can take this as point of release. At this point, we have mg and we have upthrust that is acting on this balloon. So we can label this as upthrust. As upthrust is greater, it means that there is net force on the balloon. So due to net force, this balloon will accelerate in upward direction. As this balloon will accelerate, it means that its speed is increasing. So these points, this is how you can write down your answer. And your answer has to be in a logical order and with proper reasoning, because this question they will check your logical reasoning for this part of the question. So you can write down these points. So first you can say this point, then you can say it will accelerate. You can also say its speed is increasing. So it will accelerate. Now let's say it reaches certain height. So here we have mg, and at this certain height its volume is maximum. Now we need to understand, when the balloon is rising up, atmospheric pressure is decreasing, so balloon will expand, and density of air is also decreasing, so this balloon will finally reach a maximum volume, then it will stop expanding. And then we can take another point here. At this point, this upthrust now will start decreasing, because upthrust u, this is equal to rho times v times g. Volume is constant now, we can assume it is constant, but density is decreasing. Before volume was increasing, but now volume stop expanding. As density decrease, it means upthrust will decrease. Then it will finally reach a point where upthrust is equal to mg. Upthrust is equal to mg. So at this point we can say upthrust is equal to mg. But when this balloon will further go up, now upthrust is smaller. Upthrust keep on decreasing, because when balloon is rising, density is decreasing, so it means upthrust will keep on decreasing. So at this instant, net force is in downward direction, so it means this will decelerate. Balloon is rising up, acceleration is in downward direction, so this will decelerate, and finally at one point this one will stop rising. It will stop rising. So at this point balloon will stop rising. We can say it has reached the maximum height, and the velocity of the balloon finally become equal to 0, because it is downward force is, net force is acting downward direction like a ball. Actually, if I throw the ball in upward direction, because gravity is down, ball will reach a maximum height, it will stop, then it will start falling down. So the same is happening with the balloon. Balloon speed becomes 0, at maximum height it will stop there. So these are the points we need to write down in our answer, and this is how systematically you can write down. At this point, you can, density is decreasing, you can mention. Here we can say volume is maximum, and after that upthrust start to decrease. So this is greater value of upthrust, this is, and this one is smaller. And at this point mg is equal to upthrust, and here upthrust is smaller than mg, so net force is down, acceleration is also down, and now the balloon is just like in a free fall. You throw something in upward direction, it is in free fall, gravity is down, so it will decelerate, finally its speed will be equal to 0 at maximum height. So these are the points. Let me show you the answer, how you can write down your answer in a logical order. So these are the points you have to mention in your answer. So we can say when the balloon is released, upthrust greater than weight, as we mentioned here, upthrust is greater than weight, so resultant force is upward. So we have mentioned resultant force is in upward direction. Balloon accelerates upward, so velocity of balloon increases. We have mentioned here acceleration, velocity increases. After balloon is at maximum volume, mean it has reached Vmax. Upthrust decreases as height increases, density of surrounding air decreases. We have mentioned here density decreases, volume is constant now until upthrust is less than weight. So here upthrust is less than weight, so there is resultant force downwards. Resultant force is downwards. Balloon then decelerate to rest. Finally its velocity becomes zero. A beautiful question, very nice question. And this is also in the same way you can approach if a skydiver jumps from a plane. So you can also explain answer in a similar way. But when skydiver jumps, actually we also talk about drag force. So here you need to understand upthrust decreases when density decreases. So just arrow has to be down. I have explained when density decreases, upthrust decreases. So this arrow has to be pointing in downward direction. Question 18 says a student carried out an experiment using a data logger to record the motion of a ball bearing as it falls through a liquid. For part A, state the conditions under which Stokes' law applies to an object moving through a fluid. Stokes' law we can apply when objects are spherical in shape, so we can say for small spheres, and we can apply when the flow is laminar flow, mean the speed is slow, laminar flow, and speed low speed. So this is when we can apply Stokes' law. F is equal to 6 pi eta r v. So these two conditions we have to write down for Stokes' law. So this is how you can write down your answer. In your answer you can say small spherical object moving at low speed and laminar flow. This question has 2 marks, so if you write down these 2 points you will get 2 marks. Part B says the graph obtained by the student is shown below. For part B1, explain the shape of the graph. So first of all we need to understand on y-axis we have displacement and on x-axis we have time. So the gradient of this graph, so we can say gradient of dt graph is representing velocity, So if you look at the gradient now, initially you can see the gradient is equal to 0. It means speed is equal to 0. And then if you look at the gradient, you can see this gradient is increasing. So it keeps on increasing until this point. And so we can say gradient is getting steeper. So if the gradient increase and gradient is representing velocity, so it means velocity is increasing. And after this point, if we draw a straight line, so we can see it's a straight line, means gradient is constant. So here we can say this gradient is constant, it means that v is also constant. So you can also simply say the ball bearing, it has reached terminal velocity. So it has reached terminal velocity. So these are the points you need to understand to answer this question. Now let me show you the answer, how you can write down your final answer. In your final answer, you can mention these points. You can write down, first of all, initially the velocity is 0, so the gradient is 0. As gradient is 0, it means velocity is 0. And so you will get 1 point. Then you can say as velocity increases, gradient changes, you will get 1 point, mean if you have mentioned about this part. And the last one, drag increases until terminal velocity when gradient becomes constant, mean here object is moving at constant velocity. So that is the terminal velocity, final constant velocity. So if you write on the third point, you will get another mark, and this question has 3 marks. Second part says the ball bearing had a diameter of 1.6 mm. the difference between the upthrust on the ball bearing and weight of the ball bearing is equal to this. Calculate the viscosity of the liquid. Assume that Stokes law applies. So we need to apply Stokes law for this question. So simply we can write down Stokes law. Tells us that drag force is equal to 6 pi eta RV. We need to calculate viscosity. So viscosity will be equal to F drag force divided by 6 pi R times V. We have diameter, so we can find out the radius from here. That will be equal to 0.8 millimeters. Or we can say this is 0.8 times 10 to minus 3 meters. So this one is the radius. So we have value of radius, we have value of the force. Because drag force, so it is given to us that upthrust, when the ball bearing is falling down, upthrust is in upward direction and drag force is also in upward direction and mg is acting down. So this one is mg. So it is given to us that Fd is equal to mg minus u, mean the difference between these two forces we have, and this value is given to us. So this value is the drag force. So simply we can say this is 1.45 times 10 to minus 4 Newton. So we have value of drag force, so we can simply update here. So we have 1.45 times 10 to minus 4, and this is divided by 6 pi. Value of radius we have, that is 0.8 times 10 to minus 3 meters. We need value of V. If we have value of V, we can find out viscosity, and the V is the terminal velocity when Fd is equal to mg minus u, or simply you can say the instant when drag plus upthrust, they're equal to mg, means the mg is balanced by drag force, sum of drag force and upthrust. At that instant ball bearing is falling at terminal velocity. So this velocity we have to use is terminal velocity. So this one is the terminal velocity. And here we have displacement against time graph, and the gradient of this one is equal to velocity. We have already discussed this is a straight line, so means the gradient of this line is the velocity. And so V from here, simply we can calculate value of V. So V will be equal to, we have this point, at this point we have value of displacement, that is about 11.5, and here displacement is equal to 0, and we have value of time here, and we have value of time here. Value of time here is 1.15, and here value of time is 0.6. Then if we solve this one, we will get 20.9 centimeters per second, and we can convert this one into meters. So we will have 20.9 times 10 to minus 2 meters per second, or we can say this is 0.209 meters per second. So simply we can write on here now 0.209, and if we solve this one, we will get value of viscosity, that will be equal to 0.0460 Pascal second. So this is our final answer. This is how you can calculate. Main concept is simply you need to understand F is equal to 6 pi eta R V. Then you need to identify this is the terminal velocity, and you need to understand this value is the drag force because the ball bearing is falling at constant velocity, and then you can figure out viscosity. Third part says the student heated the liquid and repeated the experiment. The ball bearing took a less time to fall a given distance in the liquid when the liquid was at a higher temperature. Explain why. Assume the density of the liquid is constant. Similar question based on the same concept you can also find in May-June 2023 section 1 paper 1. You can find the same type of question. So how we can answer this question? In order to answer this question, it is given to us density is constant. So it means that upthrust rho Vg also remain constant because density is constant, volume of fluid displaced is constant because volume of object is constant, T is constant, so it means this also remain constant. And drag force Ft, this is equal to 6 pi eta Rv. In this case, it is given to us that temperature increases. As temperature increases, viscosity will go down. As temperature increases, viscosity of the fluid will go down. Mean fluid will be less viscous. As fluid is less viscous, it means drag force will go down. So we can say as viscosity will decrease, Fd also will decrease. Radius, size of the object is constant, and if this drag force remains constant, then velocity has to increase. So why this drag force has to remain constant? When object, the ball bearing, very important point, when ball bearing reaches terminal velocity, this weight of the ball bearing, this is balanced by the upthrust and this is balanced by the drag force. So this is balanced by drag force. So from here we can say mg, this is equal to u plus ft. So when it is falling at terminal velocity, as this remain constant, this also constant, this also has to remain constant. So this is the logic why drag force has to be constant, because most of you will be struggling with this one, why drag force is constant. So drag force is constant. So if viscosity go down, this quantity is constant. So the velocity has to increase. So as velocity increase, so the distance covered, the same distance covered. So we can say as distance is equal to v times t. So any given distance, if the speed is greater, time taken to cover that distance will be shorter. So that's reason it take less time to cover a given distance. So we are talking when it is falling at terminal velocity. So these are the points you need to write down in your answer. So the first point we can say at a higher temperature, so you can say higher temperature, viscosity will go down. So you can mention this point. So this can be 1 point. Then we can also talk about this point and about this one. We can talk about forces. We can also say upthrust will remain constant, and then we can also say Ft also has to be constant when the ball bearing is falling at constant velocity. Then we can say as viscosity go down, so the velocity has to increase, speed has to increase. So as speed has increased, so the time taken to cover the same distance will be shorter. So these are the points you need to include in your answer. You can also check this paper and you can look at the question again in section 1. I hope this one is clear to you. Let me show you the answer, how you can write down your final answer. In your answer, you can mention these points. If you write on this 1 point, you will get 1 mark. This question has total 4 marks. This is the second point. You can say R is constant, F is equal to this. Drag force is less at a given speed. Means at any given speed, when the temperature is low and when temperature is higher, drag force will be lower because speed is lower. But terminal velocity will be greater. So drag force at terminal velocity is unchanged, mean it is constant. Terminal velocity is greater than before, so the ball bearing takes less time to fall the given distance. So I hope this is clear to you. At a given speed, mean if we take same speed when temperature is low and we take the same speed when temperature is higher, as at higher temperature viscosity has decreased, so this force will decrease. So this is one way you can explain. Another way to explain is at terminal speed, as I explained you here, drag force is unchanged. Means the drag force when the object is falling at terminal speed at higher temperature, and drag force when the object is falling at terminal speed at low temperature, value of drag force is the same because upthrust is the same. If you have any questions, please leave your questions in comments and I will try to answer as soon as possible. If you need more help and you want to support this work, please join Patreon, and also on Patreon you can find more resources.